Welcome back for another video. I'm Mr. Hibble. This is Algebra 2. We're looking at transformations. So, realize when you hear the word transformations or transform, what we are thinking about are changes, specifically changes to a function, a parent function, or changes to a graph. So, few types of transformations we need to know. One type we need to know is what's called a translation. A translation is a transformation in which a figure is pushed or moved from one position to another. Realize it does not turn the shape of the object, it just moves it side to side or up and down. The ways that we can move it, H, if you notice, H is inside the parentheses. Anytime you have something inside the parentheses, it always affects the horizontal. So if we have anything adding or subtracting inside the parentheses, it'll be a horizontal translation, moves it left or right. If you have something on the outside of the parentheses, that means it is a vertical change. If it is adding or subtracting on the outside, it is a vertical translation, pushing the object up or down. So with that being said, let's look at these transformations. Let's look at some graphs and what we actually mean here. Well, this first one, x squared, this is the most basic type of quadratic that we can have. A quadratic, an x squared function makes a u shape. This is the parent function for it. In this case, this quadratic will go through the origin, it'll pass through these two coordinates, and it'll start to make a u shape going like this. Okay, those lines should be a little bit straighter, not necessarily wavy, but we get the point there. But then if we start to have these values inside the quadratic or affecting the quadratic, I notice the 1 on this next problem is on the inside. Anything inside is always left or right. It's the horizontal. In this case, since it's adding, what happens is the graph will move left. The inside always does the opposite of what you expect. So if you think +1 would move a graph right, inside is always opposite. It moves the graph left 1 unit. The 3, it's on the outside. Outside is vertical. That means it's moving it up or down. Outside works normally. It would move the graph up 3. So we know this graph goes left 1, up 3, and we have some sort of quadratic or U shape from there. Same idea with the third one. Value on the inside is left and right. It's always opposite. So I hear minus. I'm thinking, okay, where's that going to go? It's going to be the opposite of what I expect. So it's going to go right 4. I see the minus on the outside. Outside works normal. Minus on the outside would mean it would be going down then. So I need to move this U shape right 4 and down 2 and have the U shape from there. Okay, this is the basic idea of what a translation does. Notice it did not change the U shape, it just moved it side to side, up and down. Other transformations are what's known as a dilation and a reflection. Dilations are known as stretches or compressions of the graph. You can stretch it vertically, making it very skinny and tall, or you can compress it vertically, smushing it together and making the graph wider or fatter. A dilation occurs whenever there is a multiplier on the function. That means we have something multiplying in front with the parentheses or with the function now. Analyzing that a value, a stretch occurs whenever the a value is greater than 1. Technically, the absolute value of a. A compression occurs whenever the absolute value of a is less than 1. But then there's also this idea of a reflection. A reflection means you have your graph. It's this U shape, and we're going to reflect it. We're going to flip it so it goes the other way instead. Okay, a reflection over the x-axis flips it upside down. This will occur whenever the a value is negative. Let's look at these examples. Number 4, then, I still see that there's a minus on the inside moving this graph right 1. I see a minus on the outside moving the graph down 2. I notice that is the same for all three of these. The next thing I notice is this value of 3 in the front, though. This value of 3, what that does is I want to know, is it bigger or smaller than 1? In this case, the 3 is larger than 1. That means there is a stretch. We are stretching this U-shaped graph by a factor of 3 now. So now our graph will become much skinnier of a U-shaped curve. But if I have a value of 1/2 instead, 1/2 is less than 1, so this is a compression. That means your graph should be getting much fatter. So taking this graph, I compress it by 1/2. This U shape now looks something like this. It's not perfect, but it is a sketch. Looking at number 6, I notice the 1/2. So I notice it's still being compressed. It doesn't matter that it's negative. It's still a value of 1/2. That is a compression. If it was -3, it would still be a stretch. The negative controls a different part. If it is a negative value in front, if it is a negative dilation, what that does is it reflects the graph. So on this one, oops, we messed up these graphs. We forgot to move them. So we do need to make sure we move them as well. These need to go right 1, down 2. This one here as well, we said right 1, down 2. And now we'll make sure we draw this one correctly. Right 1, down 2, compressed by 1/2, so it's becoming fatter. But wait a minute, we're also reflecting it. So we said that that reflection means it should be going down now instead. So we need a fat U going down instead. This is how our reflections work. Being able to identify the transformations is one part of it. Being able to create a function is another. Let's run through a problem or two real quick. I see a value in front. I'm thinking bigger or smaller than 1. 1/3 is less than 1. That means this is a compression. I look at the values, adding and subtracting, figuring out what's happening with those. The values on the inside are left or right, and always opposite of what we expect. The 4 moves it left. The 8 on the outside is either up or down. In this case, it would be moving it down. We can look at some other ones. For example, number 12. I notice this value in front is negative, so it's being reflected. I notice the 3.5 is there as well. 3.5, ignore the negative. 3.5 is larger than 1, so this is a stretch. The 5 in this case, inside, would be moving it left 5. There's nothing adding or subtracting at the end, so there's no up or down movement. Realize you do not always need a stretch or compression. For example, number 9 just has the negative. That means it's being reflected. But there is no value there for us to compare. Is it bigger or smaller than 1? So there is no compress or stretch. Instead, there is just some horizontal and vertical shifts. The last one here for us to look at, we want to let k of x be a new function that has been transformed from this quadratic such that k has been reflected over the x-axis, stretched by a factor of 3, and moved up 8. Well, reflections are negatives that are in front. Stretches are in front as well. The stretch is bigger than 1. It's a stretch by 3. Okay, that makes sense. It's moving up 8. Up and down is always on the outside, adding or subtracting. It works normally, so up would add 8. Another way we could write this, because there's nothing on the inside, would be something like this. Thank you all for watching. That is our transformations video. Come back next time.